Oh, that's the audio. You guys should all stay. This is going to be a lot of fun. I just have to find the HDMI cable. Oh, wait, I can use that. Never mind. Do you want to do just, okay. Thank you.
All right, folks, real quick, as a reminder for anybody that hasn't heard this yet, the opaque sheeting all along the back wall, along the windows, is up there for a reason. Please do not try to peek onto the field. As you're walking between east and west, make sure that you do not have your cell phone out, you do not have a camera out. If any of those events happen, you will be escorted off the premises because if the Pats start playing, then they don't want anybody taking any pictures of the plays. So right now, I'm very excited about this. We're going to have a serverless chat right now. This is Randall Hunt. He was previously of NASA and then previously of SpaceX, and then he got bored or decided that wasn't hard enough, so he went over to AWS and started doing Lambda. So with that, Randall Hunt.
Hi, everybody. Thanks so much for being here. I know you have like a choice. Do I need this down to 720?
Just swap displays.
Oh. Oh, in the presenter view? Or?
Yeah.
Gotcha.
So just you can see it down here.
Yeah.
And then just go to swap displays.
Ta-da. So do people typically do live coding at these talks? Yes. Okay. So I'm definitely going to do that at some point. So first of all, thanks to Dan for that talk earlier. It was very informative, super interesting stuff. I work at AWS. I'm a software engineer. I don't have a lofty title or anything. I have no idea why any of you should listen to me, but I'm going to blow your minds. Do you guys want to take a selfie? I'm a millennial, by the way, so I'm required to ask this question. I promise this has a point. So do you guys mind taking a quick selfie with me? I'm just going to include this group over here. They're the most attractive. So 1, 2, 3. That'll come in handy later on. So who am I? I am just a guy. You should follow me on Twitter. I'm hilarious, just like this talk should be. These slides are not just mine. It's the work of a lot of different people at AWS. And AWS, for those of you who don't know, is Amazon Web Services, and they pay my paychecks, and they're pretty cool. I used to be at SpaceX and NASA, but it turns out physicists don't make any money, and software engineers make a lot of money. So that's what I do now. True story. This is not a sales talk. If you end up using more AWS because of this, that's fine. That's great. But again, I'm just an engineer. I'm not trying to sell you on anything. Almost everything that I'm talking about today is available from multiple cloud providers. It's not just AWS stuff. And I will be talking about AWS stuff because they pay me to, and because it's fun and it's cool and I know it pretty well. But keep in mind a lot of the core paradigms that I'm going to discuss with you today apply to any cloud provider. But AWS is best. So let's take a look at the evolution of computing. We start out circa 1978, and we have all these physical servers, and we're starting to build data centers. And then we get virtual servers and data centers, whether this is KVM or Zen or whatever virtualization platform you want to use to build out all your stuff. You run these hypervisors, you keep your servers more densely packed, you have less idle capacity, all that good stuff. And we have virtual servers in the cloud, which is saying, hey, I don't want to do a 10-year lease. I don't want to build a data center. And I'm a small startup, and I just want one server for the weekend so that I can waste all of my venture capital money. Hosting a Minecraft server or something, which is totally not a thing that I did in a startup. So each progressive step gets better, right? Each level of your abstraction allows you to do more faster. You're trading your kind of upfront capital expenditure, this big investment, for operational expenditure. And in return, you get all this cool stuff. but there's still limitations, right? I still have to, if I'm running Gentoo, I have to like manage portage. So if anybody's ever, my college computer lab used Gentoo servers because, or Gentoo servers, I actually don't know if the G is hard or soft, because the professor was like obsessed with it and he thought it was the greatest distro in the world. And I remember having to deal with this package manager across a fleet of like 40 different servers, which I know is not a big data center or anything, but it was hell. Like keeping that stuff up to date, like running all of this, I don't want to do that. Like I want to write code, I want to solve problems, I want to build stuff, I want to see things happening on Twitter. Like in real life, I want to have things that work. And sitting there patching servers is a waste of my time. So we built a thing where you don't have to do that anymore. And this is what the concept of serverless is. And serverless at AWS is primarily composed of Lambda. AWS Lambda is an event-driven function as a service platform. And I will show you exactly what it is. I'll build something live. You guys can shout out suggestions. Like we really will code it live. So if you can think of something, kind of have it in the back of your mind, I'm happy to just code it from scratch right here. No pressure. I will make up my own suggestion if all of yours are scary. But all of these like things that you're used to dealing with, they go away. You don't have to deal with provisioning. You don't have to deal with utilization. You don't have to deal with availability and fault tolerance. Scaling, you don't really have to deal with. You kind of have to deal with throttling. So because you can scale pretty much endlessly with these event-driven functions, let's say you have a backing data store, right? Let's say you have an RDS, Postgres, or MySQL, or MongoDB, or you have some sort of backing relational database or database data store of some type. You don't want to have 10,000 concurrent functions hitting this thing, and then all of a sudden you knock over your database because you suddenly got 10,000 requests. So you do have to deal with throttling sometimes, but you don't have to scale the actual compute side of your problem anymore. And then you can say, oh, well, I'll just use DynamoDB and I'll use auto-scaling and all that good stuff. But not everybody does that. And then you don't have to deal with operations and management. That's a lie. You absolutely still have to deal with management. We all have bosses. It's a joke. So serverless is more secure. You don't have to deal with security. You don't have to SSH in. Although if you do want to SSH in, I have a really cool node shim that you can put into a serverless function, and you can SSH into your Lambda function. Don't recommend that. But that's also how you can run Perl or Pascal or Fortran or COBOL on your Lambda function if you really want to. There's a whole GitHub repo dedicated to running COBOL in Lambda, which is the most bass-backwards bizarre thing I've ever heard in my entire life. And these functions are ephemeral. They're short-lived. Every request has a log. It goes into like a centralized logging platform. We call it CloudWatch logs. But you could also farm it out to some other log store. And you have traceability. So you have this ability to go in and say, I want to see where this request started, where did it filter through the chain, what kind of other services did it touch, how long did it spend doing each of these things. So you have this kind of spectrum of compute options now. And previously, we only had these, right? We had this virtual machine, this container, these platforms as a service. We'll say that the infrastructure of a service is EC2 with VPCs. We have Elastic Container Service, which is kind of your Docker container kind of thing. Ooh, pardon me. I got no sleep last night, by the way. The Hilton Garden Inn that is directly next to this stadium is a terrible place. Don't stay there. And you can record that and put it online because, ugh. So I'm struggling to get my words out this morning. I apologize. So, and then you have Elastic Beanstalk, which is kind of like your application as a service. Now we have this functions as a service platform. And this is different, right? Because even with this app side of things, if we wanted to install different libraries, we still had to say, oh, I need you to do like pip install -r requirements.txt. I need you to pull stuff in. I need you to make stuff happen for me. Whereas this, we just say, here's an executable, go run it. I give no care about how or when or why it runs. If you do want to run it within a secure environment in your VPC, we can provision an ENI, which is just a lot of fancy acronyms to say that we can put it in a secure place and run it if you want. But don't do that, because security. You don't need to. These are the different building blocks for serverless applications. Being Amazon, we like to put our name in front of everything. We did not invent X-rays. That's another joke. I realize if I say it's another joke, it doesn't actually make it funny. So we either put AWS or Amazon in front of it, and that's how you know it's one of our services. We have Lambda at Edge as well, which I'll talk about a little bit later. And it changes how you deliver. This is just a really fancy animation. That's why I kept this in. Sorry, I'm just trying to get to the coding. Oh, so Stack Overflow does this survey every year, and this blew my mind, absolutely blew my mind when I saw the results. If you look for what the most loved platform is, you have Linux desktop, which anybody who's ever actually had to use one of those long-term in production, like, I don't understand why you love it. And then you have serverless, and that's like the second result. And serverless didn't even exist before 2014. I remember being in the audience at reInvent, which is a big conference that we have every year, in 2014, and we announced Lambda, and you could see there's like one half of the audience that totally got it, and they were like, this is the coolest thing ever. And it's not like it didn't exist before. There are still companies like Iron.io or Zapier that had this event-driven function as a service component where you would have basically just the code, you would paste it into some form, and that form would go and compile it and execute it for you. So it's not like it was a completely new idea, but this was the first kind of real production, like ready for you to use in multiple languages and kind of environment that worked at scale. And then the one half of the audience just loved it. They were super jazzed. They were like, this is the coolest thing ever. And the other half of the audience, typically the press corps, were just like, whoosh. They had no idea what was going on. reInvent this year in 2018. reInvent 2017, last year, no one was asking what serverless was. No one was asking what Lambda was. I keep having all of these questions about Lambda and serverless and everything. But at reInvent, everybody was asking, how can I use more of this? How can I do more with this? How can I put this into my infrastructure? And that was really fascinating for me because that's a change that's happened in 3 years in the industry. So yeah, these metrics are super out of date. They're from April 20th, 2017. So Lambda is everywhere. And when I say Lambda is everywhere, I want to point out that you can actually run Lambda on-prem. Sorry, where is this? You can run it on IoT devices. You can run it at our edge locations, our POPs. So we have like 100 POPs, points of presence all over the world. These are all connected by our private network, all that good stuff. And it can have so many different event sources. I don't want to make this salesy, so I'm going to skip through a bunch of things. There are a lot of different customers innovating with Lambda. I will tell like a very briefly personal / emotional story, so don't freak out. My brother had a heart transplant this year, and one of the companies that does a lot of the analysis for like 4-dimensional MRIs, where they do like they basically take a in-time view of the heart. So they got to use Lambda to serve the results to their clients. So they had this API gateway that was fronting this big, huge instance that was running this ML model of heart simulation, and they had this API gateway in front of it that would serve the inferences that got stored in S3 to the doctors requesting them. And so like this is a company that I met because my brother had a heart transplant, and they were using Lambda. I was like, this is the coolest thing ever. I've worked with a lot of different people who use Lambda. I have the distinct pleasure at AWS of flying around and talking with different customers and building cool stuff with them. The other really cool people that I worked with are Last.fm and Ticketmaster, and they gave me free tickets to EDC in Vegas, like free VIP tickets to EDC in Vegas. So that was a huge perk of this job. And then we have FINRA, who I think is a really cool customer. FINRA are the people who, if you want to sell your stock and you're the Intel CEO, they probably come after you afterwards. That's another joke related to Spectre and Meltdown. So what they do is they process all of these different sales of, they're basically a component of the SEC, even though they're not the SEC, that will go and make sure like all the different trades and things that are happening are within compliance rules, within the risk analysis profile that investors are allowed to do. And so what they do is they actually process 75 billion events per day. I can't even think of another thing that does 75 billion events per day. I'm sure there are plenty of things that do that. But these are real world events. These are real trades. These are real things that are happening. And they do all of this with Lambda. So, and it's not like these are just simple, small validations. Like some of these go out and they call to other external resources, right? And so they're processing all of this with Lambda, and they're able to provide significant feedback to people. That is enough salesy talk, I think. Do you guys want to code some stuff? Awesome. I have more salesy stuff right after this, so. OK, so somebody shout out an idea for a Lambda function. Don't be shy. Oh, this is called 1.5 factors of authentication, by the way. This is the subject of my rejected PyCon talk. I can tell you all about how that works. It's actually powered by a Lambda function. So really, it's like 3.5 factors of authentication. Anybody have any idea for something that you would want to build? Audience participation. OK, what about that picture we took earlier? Does anybody remember when I did the selfie with the more attractive section of the audience? I can do one with the also very attractive section of the audience if you guys would like. So I'm opening up this editor. It's like the Cloud9 IDE. And this is just basically the open source ACE editor that has, it's already in my environment. It already has my AWS credentials. It already has my Git credentials and everything configured. And when it works, that's good, but it doesn't appear to be. There we go. So this is what I was working on the other day. I think that we should open up a function that I already have. I have to change my region really fast, because we are on the East Coast today, aren't we? So we'll open this up. So these are just my deployed Lambda functions. So I can show you what the Lambda console looks like. You know you're getting serious about the coding when you roll up your sleeves. So cloud. So this is what the function looks like. Really is nope. That was something I did for my wife. That's an Alexa skill. Twitter. That's definitely not the right one. Man, maybe it's in Ohio. This is the problem with having a lot of different AWS regions, is I can never remember where I stashed my demo for the day. I did just provision it a second ago. TwitterBot. Pretty sure it's this one. OK, so you can see, oh, those are my, that's all fine. This is the Lambda console. It's not going to show me the editor just because this deployment package is over like 20 megabytes or something. But I can import this if I switch back to this other region really fast. I was in the right region. I can download this whole function. And you can see what I'm going to do with this function is I'm actually going to take all of the faces of the attractive part of the audience and replace them, because there's something much funnier that we could do with those faces. And we're going to use recognition. Recognition is this little API, where you can get, data about faces and whether they're in videos, whether they're in pictures, whatever. For instance, if I upload my badge photo, it tells me that I am 45 years old. So it's obviously very accurate. Let's see. This is my official badge photo, by the way. Don't know how that happened. And this is the label detection. I want the facial analysis. I promise there's a reason I'm wasting time doing this. I'm waiting for the image that we took earlier to sync to my computer. I don't know why it's not. So looks like a face, appears to be male, age range 38 to 57. I'm getting younger-ish, and it gives me my bounding boxes, and it gives me everything. So the advantage of this bounding box, also it gives you an angle. It makes it really easy to replace faces. So that's what we're going to do in this Lambda function. So you can see it here. I just have a recognition client. This is all in Python, by the way, which is the best language. And JavaScript is a bad language. And if you disagree, we can talk about that at length over beer. And then this is definitely a joke. JavaScript is fine. I briefly worked on the V8 JavaScript engine, and let me tell you, JavaScript is not fine. JavaScript is broken in just the most heinous, terrible, awful, terrible ways. It's like mass psychosis. It's like we all have Stockholm syndrome that we keep programming in this language, whereas Python is quite beautiful. Anyway, so what I do is I import a couple of different libraries. I take a couple of different parameters, and then I do, is this safe for work? I just do detect moderation labels, and I make sure there's no explicit nudity or anything like that, which when I've done live demos before has unfortunately been a problem. And then I do get faces, I return those faces, I build a list of bounding boxes from those faces, and then I do masked image, and I do Ninjafy, and then I do validate record, and then what I do is I just tweet, well, then I put it in DynamoDB, because why not? Because I just wanted to show off that you have all these different services, but that doesn't really matter right now. So what I do is for every record that comes in, I process the record, I do some stuff with it, and then I paste a new picture onto it. So because this is not uploading to because all of your wonderful faces are not uploading for some reason to my computer, I'm just going to check one more time. Nope. I'm just going to take my headshot, and I'll say, hey, at AWS Cloud Ninja, can you make me awesome? And this should get like a fairly instantaneous reply from that function. Oh, God. Of course, it doesn't work. I tested this literally a minute ago, and it was fine. I think you guys should tweet at it. I think you guys should tweet at it and see what happens. AWS Cloud Ninja. What did I do wrong? Well, what we can do is we can hop over to monitoring. This is definitely just a planned thing where we can go and we can debug. And we can see that we had an invocation. We can jump into the logs here. We can see that it detected nudity in that picture. It's weird. Let me just do the last 5 minutes here. OK, well, this is a great example of me coding things poorly. So we can go and we can fix it. So obviously it's not even deploying the right version. Let's not worry about it. What I can do instead is I will just create a new Lambda function that is less cool. And I'll say Python, the real language, hello world, unless you guys come up with a better idea in like the next 2 minutes here. It's just an existing role. And I have a role that just gives me access to anything because I'm a developer and I don't do ops. Don't do this in production. If you do this in production, somebody at your company is going to get really angry at you. It might be you like a few weeks from now. That's typically what happens to me. Like, I've never been angrier at another developer than I am at myself 4 months ago. So I've created this basic hello world function. And all I'm going to do is I'm just going to say hello from event, hello from event.format. And then I'll say event. And then I'll save this. And then we can invoke it. We can test it. We can say event is that Patriots Stadium VTUG thing. Test. Take the comma out. Create the event. Invoke the function. Execution succeeded. Hello from that Patriots Stadium VTUG thing. That's all well and good, right? But what's way more fun is to front that with an API. And to front that with an API, you'd think, oh, I've got to provision SSL certs, I've got to do all this whole shindig. But no, I just say I want a new API, and I say hello world, create my new edge optimized is fine. I'll say give me, I'll create a new method. I'll make this get. And then I will say I want you to invoke a Lambda function, which is this US West 2. Is that the region we're in? Yeah. And then what did I call the function? I called it hello world. That all works. I'll save this. And bada boom, bada bing, I have an API after I click deploy. And like any real developer, we're just going to deploy to prod. Worked fine in dev, ops problem now. And then if I go like this, oops, I'll make this much bigger. Can everybody see that okay? Does it need to be bigger? I'm just going to say curl. I changed my mind. I want to make this a post because I want to pass in a payload. And I could do that with a get, obviously, in the request body. But so one more thing. Just a second, sorry. US West 2, hello world. Deploy, again, to prod. And there's all this good stuff that we can do. Curl-d, and then I'm going to pass in event VTUG winter warmer. And that looks right. And then I'm going to do that URL. And then, ta-da, we have an API. And we can make this API do anything we want. And that's actually how the thing that's not working right now is supposed to work. But apparently, my face got detected as nudity, and that's just broken. So if you guys had suggestions for something that you wanted to build, I have 2 more minutes allotted to this particular section of the talk. And I would be happy to build something from scratch. That is normally what I do, but you are all very quiet. You can throw anything out there. I am confident in my ability to, I can solve the Turing problem. Oh, this is great. OK. Moving back to the presentation. So that's Lambda. That is how you kind of build things with Lambda. It's pretty straightforward. It's pretty easy to get running, get something out there deployed. My suggestion is to send me an email. My email is randhunt@amazon.com. You will get an automated reply that is given to you by a Lambda function that will give you some AWS credit code. And I'll put my email up again later. If you tweet at me, you will get an automated reply that is a Lambda function. If my mother texts me, she will get an automated reply that is a Lambda function. If you ask Alexa where I am, you will get an automated reply that's a Lambda function. I'll just demonstrate one other little amusing Lambda function that I created. I travel a lot for work. I never knew that you could message yourself before I started doing this demo. Where are you? And it says, Randall was last at Gillette Stadium 2 hours ago. And I could even where dot Randall. I could even curl, sorry, API.randman.curl com/where. I could even curl that and get a response back. And now you all know how to stalk me if that's something that you felt like doing. But I created this using Twilio, which is another company, and then your mom or your loved ones, they text you, and you can give them detailed information about where you are without actually having to be bothered to pull out your phone, which is, I think, just the worst thing in the world, but it saves me so much time. So I want to talk a little bit higher level now, since that seems to be what we're all comfortable with. And I want to talk about how we previously built a lot of monoliths. When I was at SpaceX, we had a monolith, and we tried to split that into microservices, and that was a bad idea. Monoliths probably still make sense for embedded devices, just throwing that out there. We had monoliths, and then we had this idea of microservices, and now we're kind of moving into a new phase of microservices, which are really just functions. And if I were to poll the audience, who here would say that authorization would count as a microservice? So for the purposes of any video, that was 100% of the audience. And I'm happy to inform you that all 100% of you are wrong. Authorization is not a microservice. A microservice is login. A microservice is forgot password. A microservice is sign up, which is comprised of other microservices. I've also never learned the difference between comprised and composed. I know that you're supposed to use one, and I'm sure my English teacher is rolling over in the grave right now. Actually, that's a terrible thing to say. I don't even know if she's dead. But you have these very small units of compute that coalesce into a bigger business entity. And previously, maybe you write a Flask app or a Java app or a Spring app. You have this whole XML RPC thing going on where you're shifting stuff around. That was the original microservice that we had at Amazon. Was we kind of had this XML RPC thing going on where we would just ship around these big XML blobs and say, hey, you other microservice, do this. And then Jeff Bezos famously sent an email like, everybody should switch all of their APIs to work on this private interface, this public interface, and if you have backdoors, you're in trouble. And that was kind of the beginning of AWS, to be honest. So that's how splitting monoliths looked like 10 years ago. Call it 2005, 2006. And then we get, 5 years ago, we get JSON. We even get protobuf. We get kind of binary encodings going around where we're kind of being a little smarter about how we build these things. And we get this microservices graph. And then we start sending all of this data around. We start building services on top of microservices, on top of other services. This is just a fascinating animation. I could watch it all day. And we have these kind of standard building blocks now where instead of having full servers, instead of having even containers, instead of having full Flask apps or full Java apps running, we just have code that's trying to accomplish a specific business use case. So let's say we get a notification from SQS, like we've posted something new, or somebody's added a new row to DynamoDB, or somebody's posted a new item into a Kinesis stream. We can respond to all of that with not just one Lambda function, but multiple Lambda functions. We can write different subscribers and consumers for all of these different functions. And the real power of this is that they are completely ephemeral. So when they're not running, you're not paying for them. There's no cost. We bill in gigabyte seconds. For those of you who have never heard that term before, it's like a kilowatt hour, but better. It literally says, if I use 1 gigabyte for 1 second, that is 1 gigabyte second. If I use 128 megs for 10 seconds, that is 1 gigabyte second. And we bill this in literally like 10 millisecond increments. So, and we bill EC2 by the second. So it's like you can do your kind of cost analysis. And you can provision up to 3 gigs. You have a bunch of other random functions, limitations. None of them have ever really been an issue for any of the customers that I've worked with. But you can see what this kind of starts to look like. You have API gateway, which is that thing that I just showed you where we're curling an endpoint. It's going and it's touching one Lambda function. But it could also touch something called a step function. A step function is an orchestration layer over Lambda functions that says, hey, I want you to farm this request out to a bunch of different asynchronous things that it's going to do something in the background. And when it's not running, you're not paying anything. So as an example, I had an application. I used to live in New York City. Is anybody here from New York? OK. You're all awesome. In New York, they have a train that's called the 7 train. And the 7 train takes you from Times Square or Grand Central into Queens. And it sucks. It's just like, it only runs for a brief period of time, and it is frequently down. And I lived in Queens, so I hated it. So I built isthe7trainrunning.com. And this website used to cost me $4 or $5 a month for like 100,000 hits per day or something, which is probably mostly bots, to be honest. And then I switched it to Lambda, and I have not paid a dime to run this website since then. I have had other websites. Does anybody remember getshots.com? So getshots.com, every time you did a git commit, it would take a picture, and then it would post it online for other people to make fun of you. And there was even a Chrome extension at one point that that would embed it in github.com. So like on the commit message, it would show your git shot, so you could see your shocked face. And then somebody sued me, so I had to take it down. Because I was like, it wasn't a lawsuit. It was more like, hey, remove my data. I didn't realize this was posting publicly. And I was like, it says that in really big letters. And I was working at SpaceX at the time, and we were trying to land this rocket. And I was like, I don't have time to deal with this. So I just shut the whole thing down. And I recently brought it back up. And deleting that person's data, of course. And I realized this used to cost me, with 10,000 monthly active users, it would cost me $25 to run it all monthly. Nothing, right? Now with Lambda, with S3, with all of this stuff, I'm still paying like $0. And this scales. This scales like linearly. There's a company called A Cloud Guru that does cloud training for AWS and also a couple other cloud providers. They run entirely serverlessly. So they have an S3 static web page that hosts their site, and then they have Lambda serving all of the content. And this is a full business. They just raised like $30 million or something. And I realized raising money is easy if you're in San Francisco, but they're in Australia. So it's a whole different world down there. So yeah, you kind of have to think about the way things have changed if you want to stay relevant. This is a really mean thing to say, but like, does anybody remember Polaroid? Like, I mean, what are they doing now? And I think if you want to stick around, maybe Polaroid's going to make a comeback. Like, they can have cool little augmented reality things that come out. I don't know. But if you want to stay relevant, if you want to stay on top of this stuff, you've got to understand the technology. You don't necessarily have to use it. But it would behoove everybody here to like go and figure out how to run a Lambda function. Figure out where in your business you might see some value in this. Whether it's as glue, whether it's like an automation engine to make sure you're not exposing any security or any other issues in your cloud. Maybe you want to respond to your mother's text messages. So when you model all of this, it can be somewhat difficult to kind of keep all of those abstract pieces and microservices in your mind. So we built a little framework for that. It's called SAM. It has a very cute mascot, so obviously it's a great framework. SAM is the serverless application model. And what it does is it lets you organize all of your tables, API gateways, and functions into one neat little YAML format. Does anybody know what CloudFormation is? CloudFormation is kind of a JSON or YAML specification that says, I want a data center, please spin this up for me, and we spin up a data center for you. And you can specify all of your different infrastructure in there, whether it be EC2 instances or Lambda functions. So SAM is just a transform on top of CloudFormation that takes these very, very long files, very, very verbose, boring things to read through, and it makes them short and sweet and nice. And it's an open spec, so anybody can use this. Like Lambda is currently the only thing that implements it, probably because nobody else really wants to implement another spec. I'm sure all of you have seen that XKCD where wow, there are 14 competing standards. We absolutely have to build one unifying standard. Situation 6 months later, there are 15 competing standards. There are all kinds of really useful frameworks that you can use to kind of abstract away a lot of the service development. Does anybody write Python? OK, should start. It is like the #1 language. Go look on hackerrank.com. They show you that Python is by far the most loved, awesome language, developers of all ages. And there's this framework called Zappa that basically lets you take any WSGI container, any Python app that you already have, and you just type in Zappa deploy, and with no code changes, it will start running in Lambda, which is super rad. There's also some frameworks called Chalice, which lets you kind of write things from scratch. If you have Java stuff that you want to run, whether it's Spring App or otherwise, you can do all that very easily in serverless. There are a couple different frameworks for that. One thing that I will say, if you are doing Java in Lambda, you do have to pay attention to runtime dependency injection, like OSGI style stuff. This is kind of for the Atlassian folks around. Don't do that, because you're paying for every 100 milliseconds. Like, have everything done at compile time. Like, it's fine if your executable is bigger. Like, you just want it to run. Like, don't pull down and inject things while you're paying for compute in 100 millisecond increments. It's a bad idea. We also have Golang. Does anybody use that? OK, that's also a super rad language. The only problem with Golang is after everything that you do, just like in JavaScript, you basically have to do if error. It takes me back to like writing C. Like, if error, not nil, do this. So when you've been writing Go for long enough, you just don't look at the error handling anymore. Like, you just minimize that part of the code in your mind. This is what a Chalice app looks like. It's really, really straightforward, very easy to build, and I get my Hello World app. This is what a Zappa app looks like. Again, very easy to deploy, not very difficult. And I think I'll sum up here, and then we can all get minutes of our lives back. We have this kind of continuum of deployment, and there's this for lack of a better word, there's this law of continuous silicon. Like, I can start over here. Sorry to the camera guy. I can start over here in data centers, right? And I have the compute that I want to run. I have the code that I want to run. I have the business application that I want to run. Then I can kind of go all the way over, from the data center, moving up the stack, platform as a service to functions as a service, and then I even can go all the way down, and I can put these same Lambda functions on IoT devices. I can put them on embedded devices that are out there in the world. Things like doorbells. You could, I built this thing called Knockatron. I build too many things that I never finish. All of them would make great businesses if anybody's an investor, by the way. Just throwing that out there. You could have this doorbell that goes, checks recognition, says, hey, is this person allowed into my house? If so, unlock the door. If not, don't. But it's still the same code, right? It's the same idea. It's the same business unit that you're executing. And I can do that now. Like, I can define a Lambda function. I can have it run on a Raspberry Pi. I could have it run on even, like, we have stuff that can run on a microcontroller now. With this I don't remember the not code name of the service, because they change all the code names after we launch them. Free RTOS we have for microcontrollers. Like, you can put Lambda functions on all of these devices. You can manage them, deploy them, update them. And I think it's a very powerful paradigm that is going to change the industry and make us all a lot smarter. And these functions, they work everywhere in this continuum. If you guys are interested in live coding, I live code most Tuesdays and Thursdays on twitch.tv/AWS. I basically take ideas from the audience, and then we build them. If any of them ever gets rich and famous, I have full rights to it, by the way. So just because it's your idea, I'm the one building it. I intend on, no, I'm kidding. I'm pretty sure Amazon owns everything. that I make while I'm on that channel. I also have a personal channel where I do other coding tasks, and I also play video games because, again, I'm a millennial. And that's really all that I have for you guys today. Again, if you want me to code something, I can. I didn't get many suggestions. Thank you very much for taking the time to come here. I know you had a choice of talks today. I hope you found this valuable. I am going to put my email up now. No, I'm not. OK, so shoot me an email. You should get an automated response, unless that's broken too because of the nudity detector. I don't know why it would be. So thank you guys very much. Ephemeral. To instantiate? So the question is, all of this goes away. Do I have to worry about cold starts? So here's the thing. Let's just go and I have something I can show you. X-ray. In our typical Amazon fashion, we put our name in front of everything. So there's a service called X-ray. Oh, you're not seeing the screen? Oh, sorry. Is there a way to show that again? There's no way to show that again? Anyway, there's a service called X-ray that will let you kind of dig into the instantiations of your various Lambda functions. And the cold start time for Python 3 environments, by the way, so yeah, here you can see it. So this is one of the environments. We can dig deep here. Let me look at one of the traces. It was 66 milliseconds to invoke. So that was a warm container. I could show you a cold container on Python 3, but frankly, there's no difference in time to instantiate. The only thing that takes a significant amount of time to instantiate, and this is on the order of seconds, by the way, is Java. So Go actually starts running even from a cold start, where the containers aren't warm or anything. It starts running in milliseconds, like single-digit milliseconds. So it's a pretty powerful paradigm when you consider that. Does this remotely make your concern about waiting for these to come up go away? Yes. Yes. So there's a framework called PyRen, which people are using. So the question was, you're going to have this function being called frequently. It's going to be called from multiple event sources, and it's going to be doing all kinds of things. Do I need to get off stage or anything? Or I have time? OK, perfect. So the idea behind PyRen is that you have vastly more bandwidth and vastly more parallelism than you would have otherwise, even remotely available to you. So PyRen, they achieved, I think it was like 75 teraflops of compute and I think it was like 60 terabits per second to S3, which is absurd. So you can do a lot, even if you're calling these functions very quickly. You could have them being invoked hundreds of thousands of times per second, and it would be fine. Like the service itself will scale endlessly. It's more, there are some default limits in place. I think of 1,000 simultaneous concurrent executions that just, we don't want you to have to wake up suddenly to a very rude credit card bill. We kind of prevent that. But it's to lift that, it's saying it's an automated thing. You say, hey, I know what I'm doing. Let me pay you lots of money. As an example, there's the Washington Post. Every time somebody hits one of their web pages, they are being served with Lambda. People are doing data science using Lambda. People are doing artificial intelligence using Lambda. They're doing last layer tuning of models using Lambda. It is a pretty versatile service that's used across the industry. So let's say you spin up a new instance, and you want to make sure that it works with all various security policies in place within your organization. There's something called config rules. So config rules responds to any activity in your AWS account, and it fires off a Lambda function, and that Lambda function can say, yes, this is good, or it can say, no, this person is bad, and they're no longer allowed to spin up instances anymore. It is extremely, extremely powerful, and I think to really grok it, for lack of a better word, you have to open up the console, you have to go and actually write and build a function, and then a lot of things start to come together in your mind. And I would be happy to facilitate that with free AWS credits, which is what the automated email that you should get from me will contain. Any other questions? Wonderful. Thank you all so much for your time and your attention. This is a fun conference. I'm sad that I can't steal the Pats playoffs. So apparently New England is very good at this football thing. Because you guys get here a lot. All right, thanks.